We're now going to take the rules that we learned about groundwater flow and its graphical depiction and apply them to a really classic problem in hydrogeology, which is flow under an impermeable dam. So let's say that this is your dam here. And it's basically totally impermeable. And then let's say that's somewhere at depth, there's another impermeable layer. And in between, there's the ground surface, and there's some aquifer in here. And in this example, the water table, there's ponded water, there's a reservoir or a lake over here. So we've got water here. And then on the other side of the dam, it's just, the water table is just at the ground surface here. And we will say that this height here, let's say this is 100 meters above our data. And that this one here we'll say is 60, maybe not perfectly drawn to scale. Okay. We know that at this water table and at this water table, the head is the elevation head plus the pressure head. We know the pressure head, if we're using gauge pressure, is atmospheric and therefore 0. And so we know that the hydraulic head here is everywhere equal to the elevation. And therefore this is a constant head boundary. Specifically, it's an equipotential line of head, and its value is going to be 60. Over here, it's the same thing. This is a constant head boundary. We can describe it as being an equipotential line. And the head here is going to be 100 meters. What is the head right here? Well, we're just sitting under a column of water here. And so the amount that we lose in elevation head here, we gain in pressure head because there's this overlying weight of water. And so this is also an equipotential line here, where the head is 100 meters. Okay. The challenge is to describe how water is flowing beneath this dam. And we are going to use our intuition here. And we know, for example, that in the last video we said equipotential lines must meet these impermeable no-flow boundaries at right angles. And so if this is 100 here, and this is 60, we're going to say that somewhere in between here, there's an equipotential line that's just vertical, that's halfway in between these, because this is just a homogeneous, isotropic, steady-state system that has a value of 80. It meets the impermeable boundary at right angles. And we also know that there must be two other flow lines somewhere in here. I don't know exactly where they are, but I'm going to kind of draw them like this. These are two other equipotential lines, and we'll label these 90 and 70. So we have our distribution of head in the subsurface depicted with equipotential lines. We now need to draw the flow line. So just to emphasize this, all of these are equipotentials, and the number represents their head in meters. The rule for drawing our flow lines was that the flow must everywhere be perpendicular to equipotential lines. And we also know that the flow must be going from high head to low head. So it's starting out, it's flowing straight down because it's at a right angle here. But I know that the flow's got a curve because it needs to meet this equipotential at another right angle, curve a little bit more, and then come up somewhere over here. And there's a certain symmetry in this problem, where everything on this side in the subsurface is going to look like everything on this side. And I can draw another flow line here. And so we've used our rules to draw the equipotentials based on the boundary conditions of no flow. And once we've got our equipotentials, we're now drawing in our flow lines here. There are some more considerations if you want to draw this extremely accurately regarding the amount of flow and the spacing of these flow lines, but this is the general idea. And it's definitely a bit of an art. There's some iterative trial and error to get this right. But this is the general depiction of how, using some basic knowledge about the system and some basic rules, you could predict that the flow under the dam in this aquifer is going to follow this arcuate pathway, flowing down away from the bottom of the lake or the reservoir, under the dam, and then flowing back up towards the water table here on the other side.